Leaving Cert Higher Level 2019, Paper 1, Question 4. So the part A here says find the integral of 4x cubed minus 6x plus 10 with respect to x. Okay, so let's start this off. So when you're integrating with respect to x, you're gonna increase the power of x by 1 and then divide by the new power. So if we integrate 4x cubed, we're going to add, as I say, we're going to add 1 to the power here, so it's going to become 4x to the power of 4 divided by the new power, which is 4, minus here you're going to have, again, add 1 to the power, and then divide by the new power. Now there's no x here, but when you're integrating a constant with respect to x, you just add x on at the end. So plus 10x, and then you're going to have a plus c here, because it's what we call an indefinite integral. There are no limits here. All we then have to do is just simplify it. So the 4's are going to cancel here, so we're left with x to the 4 minus 2 into 6 goes 3 times, so it's minus 3x squared. We've got then plus 10x, and then a plus c at the end. And that's part A completed. Now part B here says part of the graph of a cubic function f of x is shown below, graph not to scale. The graph cuts the x-axis at the 3 points A, B and C. And we're given the coordinates of A, they're 2, 0. Alright, now the part 1 here says given that f dash of x is equal to 6x squared minus 54x plus 109, show that f of x is given by 2x cubed minus 27x squared plus 109x minus 126. So we're given the derivative, and we're asked to find the original function. So if we're given the derivative, to get the original function, we've got to do the opposite of differentiating. We're going to have to integrate this. So f of x here is going to be found by integrating the first derivative there. We're given the first derivative. So for now I'm going to write down it's going to be the integral of f dash of x dx. So we're told here that the first derivative is 6x squared minus 54x plus 109. So we're now going to integrate this in order to get our original function. So again, we're going to do the same thing that we did earlier. So we're going to add 1 to the power and then divide by the new power. So we're going to have a 6x cubed over 3 minus 54x squared over 2, and then plus 109x. And again here we're going to have a plus c. So yeah, just tidying this up then, this becomes 2x cubed minus 2 into 54 goes 27 times, so it's 27x squared plus 109x plus c. Now, as we can see though, there's no plus c in what they have. They want to show that f of x is given by that function. We have to come up with this minus 126. Our job now is to show that this unknown constant is that minus 126. And the way we're going to do that is this curve here represents f of x. And as we can see here, the point 2, 0 definitely lies on the function. So yeah, so first of all what we'll do here, we'll just replace f of x with y. So y is equal to that. Now given that we know that 2 zeros on the function, we'll just write that in first maybe. So I'm going to say here that a 2, 0 lies on the function, or the curve you could say, i.e. when x equals 2, y is equal to 0. Alright. So we're going to replace x here with 2 and y with 0. So we're going to have then 0 is equal to 2 by 2 cubed minus 27 by 2 squared plus 109 by 2 plus c. So now the only unknown in this equation is c, so we should now be able to get the value of c. So 0 is equal then to, well, 2 by 2 cubed, that's going to give us a total of 16, minus 27 by 4, that's going to give us 108, and then 109 by 2, that's 218, plus c. So let's bring this c over here and make it a minus. So minus c then, 16 minus 108 plus 218, well, that will actually give us 126. So if minus c is equal to 126, multiplying both sides by minus 1, c will end up being minus 126. So there's c found, so now we can then put that back into here. And let's write it again as f of x. So f of x then is indeed equal to 2x cubed minus 27x squared plus 109x and then minus 126, and that is as required. Alright, so that's B part 1 done. B part 2 then, it says find the coordinates of the point B and the point C. So going back to our diagram here, B and C lie on the x-axis. Right, so we've got to find out the coordinates of them. Well, because they lie on the x-axis there, the y-coordinates will be 0. It's a question of what will the x coordinates be, right? So we're talking again about this function here. So the function that we're dealing, now we know the actual function itself. So f of x is 2x cubed minus 27x squared plus 109x minus 126. Now, alright, so again, you could call this y. So we want to find out where the function equals 0. Alright, so yeah, we want to well, let's maybe write this here as y. So y is equal to yeah, y is equal to, now to find out where a function cuts the x-axis, you want to let y equal 0. So the equation we want to solve here is this: 0 is equal to 2x cubed minus 27x squared plus 109x minus 126. So we've got a cubic equation to solve. So what I'll do here, I'm going to let this side of the equation be f of x. That's going to be my f of x here. Now, we know from earlier that when x is 2, y is 0, or f of 2 equals 0 in other words. So we can say here, from earlier, I'll just write this in. So from earlier, we know that f of 2 is equal to 0. So what that's going to mean is this. Hence, x minus 2 is a factor of f of x. And that comes from the factor theorem. So what we can now do then is, if x minus 2 is a factor of f of x, it'll divide into it evenly. So let's do that. Let's divide it in. So we're going to be dividing x minus 2 here into f of x. So f of x being the right hand side here of the equation, so 2x cubed minus 27x squared plus 109x minus 126. So doing long division now, if we divide x into 2x cubed, we're going to get 2x squared. I'm going to put that above the x squared term there. So 2x squared by x is 2x cubed. 2x squared by minus 2 is minus 4x squared. What we're then going to do is change the signs here. So I'm going to make that a minus and make that a plus. They're going to cancel. So minus 27x squared plus 4x squared is minus 23x squared. Then let's bring the 109x down. So plus 109x. And then repeating the procedure now. So dividing x into minus 23x squared, we're going to get minus 23x. So then minus 23x by x is minus 23x squared. And minus 23x by minus 2 is plus 46x. Again, we're going to change our signs here. Make that a plus and make that a minus. So these cancel. So plus 109x minus 46x. That's going to give us 63x. And then let's bring the minus 126 down. And again, start the procedure again. So x into 63x is going to give us plus 63 up here. So then 63 by x is 63x. 63 by minus 2 is minus 126. Again, changing the signs here, make that a minus, make that a plus. They cancel and they cancel. So yeah, so the equation that we're trying to solve is 2x cubed minus 27x squared plus 109x minus 126. We had that equal to 0 earlier on. So this is the equation that we're trying to solve. Now, we divided x minus 2 into this, and we got 2x squared minus 23x plus 63, and we got a remainder of 0. What that means is, it means that x minus 2 multiplied by 2x squared minus 23x plus 63 is the same thing as the left-hand side of this equation. So I can replace the left-hand side with x minus 2 by then 2x squared minus 23x plus 63. Now what we have is we've got two things multiplied by each other equaling 0. Therefore the first is going to equal 0, or the second is going to equal 0. So if x minus 2 equals 0, then x is equal to 2. But that comes from the point A. To get the x coordinates of b and c, here we need to solve this. Now this can be factorized. So we're going to be able to factorize it into, well, we're going to break it into 2x and x to start with. And then 63, we're going to break that into 9 and 7. And then that's a plus there. Let's make them both minus. That would give us the minus 23x in the middle. So then 2x minus 9 equals 0, or x minus 7 equals 0. So then, well, 2x is equal to 9. X there is going to be, well, you could say 4.5 if you want, or 9 over 2, doesn't matter. And then here x is equal to 7. So they're the other two places on the x-axis where that curve goes through. So it goes through 2. Again, the diagram is up here. It goes through 2, but it also cuts the x-axis at 2 other locations. And the x-coordinates of those 2 locations are 4.5 and 7. And again, like I said earlier, the y-coordinates are 0. So this one has to correspond to b. So b is going to be 4.50, and the c there is going to be 70. And that is question 4 completed.